So I made this power board for the induction heater, but I don't have that hooked up right now. Just kind of going over the interlocking safety features, which is basically just a current trip relay. So I actually found this little guy that I scrapped from somewhere, which is pretty cool. It's just a CT that's got a normally open relay where you can adjust the amount of current that's going to cause it to trip. So it's got a status open and closed. You basically run AC current through it, and it'll power up the little circuitry. Up at a certain voltage, you get like a little green or a red light or something like that. So that's pretty cool. That makes it easy to have a reliable way to have an instant current trip. So basically the whole point of that would be, obviously you're going to have breakers. I guess in my case, I don't like the wiring in my house. I don't really ever want to be pushing the any of the 15 amp circuits too much. Try to throw a 10 amp breaker down the line. So I'm hoping this would open up before it does up in the panel. And then at the same time, I also don't want this to be dwelling at somewhere around, the 18 amp region or something like that for too long, which it probably will. I would assume, it says it's a C curve, so this is probably going to take something like 40-50 amps for it to trip in about a second. So the idea would be, okay, I can set this anywhere from, it actually goes down really low up to, I don't remember right now, like 75 amps, something like that. So I can set this to trip at something like, 16, 17 amps. There's going to be a point there where I feel like just the power going into wherever I'm running at the time is going to be, I don't want to go beyond that. But, again, that might more likely just be the case of me trying to limit what I'm running through my circuit at home. So basically, you can find these for pretty cheap, I realized. Well, not that particular one, but here's one on Amazon. It's like 16 bucks, pretty cool, but you can see basically the same thing. It's just got a normally open relay. That one does up to 30 amps, so not bad. So anyway, I started kind of slapping this together as I went with all the junk parts I had, trying to make use of them. And I got to the point where I thought, all right, well, let me just try to do it this way, where I'm going to use a transformer. This I'm probably going to need to beef up. Most of the ones that I seem to find nowadays are, 40 VA. To go any higher, they get pretty expensive. So I don't know. I might just break down and stack another one or something like that. But let's just say this is probably going to get hot if I leave it running for way too long with everything going. With the control power actually out also into whatever I'm running. It takes a lot of gate drive power, let's just say. So that would be that deal. So I have my 24 volt main power board control, and then obviously power out in this case, it's about 20 volts, let's just say, but I'm not going to use that. So basically what I ended up doing was I got another little relay board down here. So I'm running all 24 volt stuff. So the idea is, okay, when I have control power going, I obviously want the contactor in an open state. And let's just say, even if it closes, I also want it to open up when I lose control power, right? So that's the idea. So the whole thing is, if you're going to use a circuit like this and you don't actually buy some other type of like latching relay setup, then you're going to have to make it latch yourself. So that's basically what I'm doing here with some interlocking contactors, interlocking switches basically. So I've got an auxiliary right here on this contactor. It's got normally open and normally closed. Likewise, I'm going to have normally open, normally closed on another little guy down here. I've got the same thing on this relay right here, which is a dual relay, so it's got isolated channels. And then I basically just turn this into like a little Precharge circuit. So basically the idea is, okay, at a certain point, this thing's going to take this normally open relay and it's going to close it. So, I'm just going to use that as a switch which in this case I'm just running my 24 volts and all these various normally open and normally closed little status indicators. And basically the idea obviously is once this thing trips and closes, then it's going to open the contactor back up. Now as far as the latching, that's pretty simple. You basically just have a button. In this case I'm just using this momentary button. I've got a little LED here that's getting power from a normally closed position. So it's just showing, okay, the contactor's open. You now have to engage it by pushing this button. So basically what happens is when I push this button and then I send power to the coil, which closes the contactor, it's also going to close the normally open contact, at which point that's also going to run power back into its own coil. So it's just keeping itself closed, right? So then the idea there is obviously you just need to break power to it, just open the loop. That's why, push the button, then what was normally closed is now normally open on this small one. Vice versa for this indicator here showing me that, okay, your contactor is now closed. And then, also over here, this is just showing me, yes, the relay is now closed. So basically, the idea there is now all I have to do is use this normally open switch here to now close, which will really just trigger this relay down here, which will then open power back up to this guy, which is going to leave it open, right? Simple as that. In this case, I decided to turn this into a little pre-charge circuit, right? So I need to beef up all these wires. I need to beef this up. This is all just temporary because this is only a 10 amp relay. First, I was going to just pair up the channels to give me 20 amps, but then I decided I wanted the indicators instead. So basically the idea is I've got a pre-charge resistor down here. It's a pretty big one. It's like 220 ohms, something like that. But it should be fine. I might need to recalculate that or something, but when it comes to stuff that'll really need it, like my QCW stuff, I'll probably just add my own to those boards, right? But this should be fine. So basically the idea is once this contactor closes and this relay closes, which should more or less close around at the same time, but with a delay, let's say, because all the relay's doing is it's just shorting out the resistor. So as soon as it closes, you're going to have current limiting through the resistor, which you don't want to leave in line at all times. You want to shunt that out. So basically the only issue there is, you're needing a delay circuit. So in this case, I went the lazy route. Again, I'm going to change that out later to something more reliable. But I just decided to use, just resistor current limiting and a little bank of capacitors to, slowly charge up until they reach a point where they trigger this coil right here, which is just it's a little bit harder to do as a 5-volt coil. So I had to be very precise with these values. I just wanted to show the effect. So the whole idea is there for only like a, even less than a second or so. This resistor is going to be in line, which, ideally charge up the capacitors enough to where when I then bypass it, shun it out by closing the contacts, then you're not going to dump a whole lot of inrush current. So that's, again, this is just basic pre-charge stuff. Basically, when I turn this on and then I close the contactor, then for some moment in time, this red indicator is just showing, okay, well, your contactor's closed, but the pre-charge relay has not closed yet. So that should only stay lit for a fraction of a second. Then the green one will kick over and say, okay, now your relay is closed and you're good to go, and you don't have your resistor still just in line. And again, that's just using this other channel here for that, but ideally this would be some type of contactor that has an auxiliary, or, let's just say it'd be a 3-pole or something, and you just use an extra pole, right? But that's basically how that works. So again, turn it on, and the red LED only stays on for just a moment. Ideally, I'd like to be able to adjust that a little bit more, but again, I don't have a whole lot of timing on that with this tossed together circuit that I made. But yeah, that's how that works. So that's pretty cool. And kind of simulate what would happen just by shorting out these contacts here. All right, so I'm going to test it with this resistor here I've got, but Again, you know, I feel like that's an extra little level of safety that's pretty cool. The whole point being, you want to save fuses. Having to replace fuses all the time is pretty ridiculous. So if you've ever got some overcurrent or inrush situation, then hopefully that would open up. So I'm also hoping that what might happen is, let's just say my precharge was not up to snuff. Then depending on what I set this to, then, you know, as soon as I close the contactor, if I got too big of a capacitive load there and it's trying to charge up, which is basically like a dead short, then this thing should trigger, open back up, which would kind of tell me, it's like, all right, your precharge ain't cutting it, right? All right, so I've got the controls going, and I've got this meter reading the amps going into this resistive load right here. And I've set the trip at just a little bit over 2 amps, something like that. So I'm going to engage the contactor and then slowly ramp the voltage up. And let's see. So I'm cutting it up, and I'm going to slowly bring it to about 2 amps. You can see immediately triggers, then kicks everything out, right? So I mean, ideally I'm gonna set that closer to 16 amps, something like that, 18 amps tops. But yeah, that's pretty much how that works. So that's pretty cool. Let's say I just leave it where it's at and then try to re-engage it, then actually comes on just for a little bit, so it's not an immediate thing, but you know, still kicks it out, so that's cool. I don't know if I need to worry about that or what, since I'm basically just looking for a region that's a whole lot closer than what a breaker is going to do at the rated amps or a little bit below it. Then that actually works fine, because I don't know, that takes like a second or something like that. So, which I guess, by the way, part of that second also is the precharge, so it's not actually pulling the amps. That tiny fraction where the red light's on, right?